Welcome to the Carboline Tech Service Podcast, the go-to industrial coatings podcast. Here are your hosts, Jack Walker and Paul Atzemis.
Be sure to hit like, subscribe, and set your notifications to on so you never miss any important YouTube content from Carboline. Welcome to another edition of the Carboline Tech Service Podcast. I'm Jack Walker. With me, as always, is Mr. Paul Atzemis. And Paul, how's it going today?
You know, Jack, it's going pretty well. I feel a little odd with it just being the two of us on here. It's been a while since it was just us.
It's a little lonely. Maybe if we showered more frequently or something like that, we could get some guests to come on the show. We're
still locked in our own rooms. I don't know how we don't have smell-o-vision.
Wouldn't that be cool, though? Scratch and sniff TV, fourth dimension. Make some of those horror movies just a little different.
Yeah, it sure would. Yep.
Oh, so today we're going to talk about one of my favorite topics, PCP.
Who are you kidding?
Favorite you missed topic? The joke. PCP.
Yeah, you know me.
No, that's like I will never forget being in like 5th grade and the DARE officer talking about the crazy stuff that people do when they're on PCP. And I feel like for the younger folk watching, that's like the 2021 version of bath salts.
Yeah, it probably is.
So no, we're not really going to talk about PCP, the drug. We're going to talk about PCP, pre-construction primers. And they're one of the many tools that you have in your toolbox as a coating person. And they're a little bit different than the standard zinc primers. And we're going to kind of get in and talk about how they're used, how they can save you a lot of money, and those kinds of things.
That's right. And one of the first things that we see when we talk about these pre-construction primers, there's really not a good industry standard that defines exactly what it is that you need to be using. There's a lot of them that kind of are close to it and they walk right along the edge, but none of them actually define it. And, so as you're doing research and you're thinking about them and you're talking about them, a couple of the big ones that come up, NACE has some references to it. SSPC has some references to it. The IMO, the International Maritime Organization, has a lot that they've done with this. So has the ABS, the American Bureau of Shipping, and the Department of Defense with the United States government. But they all just kind of say, here's what we want them to do, but none of them actually define it like we do with a lot of other coatings or coating systems. So there's a lot of leeway to them.
Sure. So I think that's where we're going to start. Let's just go ahead and define what we are going to call as pre-construction primers. Those are, they're going to be zinc loaded, usually less filled than your traditional zinc coating. They are going to go on at a really fine thickness, usually less than a mil or 25 microns. If we really want to get international, like 12 to 25 microns. And then when we look at it, they are able to be welded through. And that's the important part because they go on prior to any fabrication that is done with these steel members and steel plates.
So on that point, Jack hit on a really important topic. The idea behind the pre-construction primer is at the time that the steel is fabricated, when it is produced, whether it's rolled out into sheets or into steel beams, whatever the form it's going to take, at that point, when the fabricator runs it through whatever sort of blast equipment that they're using, typically it's something that's going to be very efficient. It's going to create very uniform blast profiles. But the problem is they've removed the mill scale and now they have this exposed steel and they don't want it to rust. They've created a clean and uniform surface that they need to protect. That's what these are meant to do. So if they're able to put on something that dries relatively quick, they don't have to worry about it sticking together because you can stack zinc-coated steel panels and they don't typically stick together if you've allowed them to cure. They cure pretty well. They will stand up to a lot of abuse and still perform their function of allowing the profile and the cleanliness to maintain on the steel. So now you've got a uniform surface that you're able to use when you start actually putting together the parts when you get to the job site. When you start the actual erecting of the building or the structure, whatever it is, they're uniform and they give you a good working platform to start with.
In fact, these primers go on so thin that traditionally they are part of some automated system. They're not always actually applied by human hand. That's one of the reasons why they're really not practical for field application, because when you apply them in the field, I defy you to find somebody who can regularly, uniformly apply a coating at a 0.5 mil thick.
And that's a great point, Jack, that you have it on very thin, but it is applied very uniformly. Mm-hmm. You know, these automated processes allow for a uniform surface, and that uniformity makes for very predictable outcomes when they start putting stuff together. So if you have a welder who needs to do welding and everything was applied at the same thickness, he has a very clear understanding of how is this material going to affect his weld. Now, ideally, it doesn't affect his weld. And if it was applied properly and the right primer was chosen, it won't. So that's really the idea, that he's able to then go through his weld. It's a primer that doesn't have to be removed. It doesn't have any hugely toxic effects when it's being burned, because that's essentially what's happening. They're going to burn the metal together, and that's what's going on. So all of these are meant to help aid in the speed and efficiency of putting the building together on a job site.
Yeah, I actually read a study today that said that the presence of these weldable inorganic zinc-rich primers at the presence of a weld could actually promote better corrosion protection within the weld and at the weld spot itself. Just introducing and burning through that zinc, the chemical process that happens is actually promotes corrosion prevention while it's sitting there waiting to be erected. You know, the idea that these, and that's very distinct points too that you made, because you talked about how the weld's uniformity you were building on for me, and how it's supposed to give a good weld. But if you go too thick with these primers, that's where you get bad welds, and you get your structure isn't as strong as it's supposed to be, and that causes major problems, as one could imagine. And they actually had to get away. That's why they developed these primers, is because the big thing that these primers do is they allow for contractors to have the ability to save money in a couple significant steps along the construction process.
That's right. And one of the things that it will allow is, most scenarios, we're talking about high performance coating systems. Mm-hmm. You know, you're going to be doing these when somebody's going to be following it up with some sort of epoxy system, maybe a fire protection system, but there's going to be some sort of high performance system. And inorganic zinc in and of itself does really well in these conditions and situations. So it gives a great substrate that a lot of different types of materials stick to really well. You know, we've talked about inorganic zinc in several different podcasts before. I couldn't even begin to count them all. Probably 10 times we've talked about it.
Yeah.
And that kind of a surface really helps aid in the entire coating process. And you're starting every one of those off with an inorganic zinc, which just give you that galvanic protection that you don't get with any other type of coating. And it lets you start with a fantastic foundation for your coating system.
All right, Paul, we are going to talk a little bit about the Simstone System Selector Guide. This is a brand new document brought to you by Carboline to help you better navigate our secondary containment line. Paul, why don't you tell them a little bit about this guide?
Yeah, so one of the really nice things about this guide is just how interactive it is. This guide goes and breaks down on dozens and dozens of different common chemicals that you're going to see in the industrial spaces. And it lets you know, are you talking about foot traffic? Do you have forklift traffic? traffic? Is this a truck loading zone? And it breaks down each system by what kind of traffic can it tolerate? What kind of system do you have to install? And the interactive part is when you go to the website and you go to the marketing page and you download this document, it's interactive to the point where you click on the button and it opens up the system information sheet for that product. So it will tell you about the full aggregate filled coating system, or a neat coat system if it's a neat, or a fabric reinforced system. Every one of those are linked right there to it. So there's no guessing, there's no hunting around. You don't have to know how to maneuver the website. Just click on that and it takes you right to the sheet that gives a description of what coatings are needed and how to order and generally install that system.
Yeah, so if you're a specifier and you're out there and you're working on secondary containment systems, you should use this guide, as it'll give you everything you need to know to write a secondary containment specification. That's the Simstone Selector Guide by Carboline at www.carboline.com. Yeah. And traditionally what would happen is with these pre-construction primers, as they were developed and they began to use, you saw that, you know, it was doing everything they expected to do. It was protecting the steel on the yards before it was sent to the site to erect. It was protecting them during erection, during shipping. So you have less corrosion happening to your steel throughout the entire corrosion process, which makes it cheaper when they come in to paint, because there's not as, you know, the steel's in good condition. Everybody knows, and we did a whole series on the cost of coatings, but the better condition that your substrate is in, generally the cheaper the paint job is going to be. So one of the things that they did originally with these PCPs, or pre-construction primers, is that they would remove them prior to applying a coating. And the thought there is they were surely contaminated in the process, and that they really didn't know the effect that the pre-construction primer had on the stability of the entire coating system, mainly because one of the things that's really weak in these pre-construction primers is the cohesive strength of the coating themselves. And that's another reason why you got to stay thin. If you get them on too thick, they want to split within the film itself. So you have to keep them thin for that reason, but they're still not great with cohesive strength. So this is always one of the major concerns that came with pre-construction primers. And so the Navy set out and did a pretty major study. Paul, why don't you tell them about that study?
Yeah, so really, with the help of some engineering firms, the IMO and the ABS, they've done extensive studies that show that these primers really there was no difficult to remove contaminations in most cases. They held up well. They had some great side-by-side comparisons where they were able to put multiple different systems together with multiple surface prep conditions, multiple exposures. Some of them they removed, some of them they didn't remove, and they were able to do side-by-side comparisons in the same space so that it was really representative. And what they found was the pre-construction primers really did improve the overall performance, and there was no reason to remove them. So you were just adding in an additional step and removing a product that was helpful to their scenario. It was helpful to the set of conditions. And I think one of the things, you know, the marine industry is kind of at the forefront of all this, primarily because of the way they build a boat. You know,
sure, yeah.
Parts are made, and they're usually made and brought in units, and they're assembled in cubes, for lack of a better term, like building units that are put together, and then they're welded on site and they're bolted together on site. But so everything had a primer, and they work in an area that, it's a boat. So the areas have a lot of moisture in the area. There's a high humidity. And if they don't have to get into those tight, hard to reach positions and remove that primer, it really helps improve the coating system and speed along the process and make a boat more affordable and creates less waste in the process.
Yeah, I think the Navy study identified, and I apologize, I'm not sure how many years it is old, but they acknowledged that through the course of the study, they were able to save $7 million a year by not having to remove that pre-construction primer.
That's right. And that's just one small industry segment. Think of all the places that are making boats every year, the constant production that's going through. And if everybody is saving that much money on it, it makes the cost of moving goods and transportation that much better for everybody and less waste. They're not creating something that has to be dealt with.
Mm-hmm. And I don't want everybody to think that pre-construction primers are perfect for every industrial coatings job. They really have one specific purpose and they do it very well. And that's for any kind of steel that's manufactured and assembled later, whether it's in that specific shop that they do the assembly, or like a bolted tank, any kind of modular steel design where they are going to erect it later, but they need corrosion protection. So when you look at these pre-construction primers, know that we are talking about zinc-rich coatings. They're usually lower in zinc content than your standard inorganic zinc-rich coatings. They are weldable, so you can weld through them. They do not cause any kind of problems. The zinc is important for that. And we are finding out now through more and more studies, and it's more common in the marine industry for them to uphold this practice of using pre-construction primers. If you're more interested in pre-construction primers from Carboline, know that we have a wide offering. The two main ones are our CarboWeld 14WB and 9WB, but also if you were doing like a pre-construction water tank, there is our CarboZank 8703. All work well. The 8703 has your NSF certification that you need for that water tank. But yeah, that's pre-construction primers in a nutshell. So Paul, another good episode.
Excellent.
All right, man. We'll see you next time.
All right.